Welcome to the November online meetup, Rancher Continuous Deployment. I am joined today by my esteemed colleagues, Bill Maxwell and Gaurav Mehta. You guys want to say hello?
Hi, everyone.
Bill's camera shy, but he's here. He's here. All right. So first things first, if you've ever been to one of these before, you know it's not a webinar. This is Rancher. It's a meetup. We're here to show you cool stuff, answer your questions, and we all really hope that the gods of the demo will smile upon us today, because they don't always smile upon us. And that's fine. So we book 90 minutes for this. Whatever, like it could go long. If we run out of stuff to talk about, it'll go short. I don't think that's ever happened in the history of Rancher. So this is for you. Ask questions. There's a questions panel in the GoToWebinar thingy over wherever it is on your screen. So when you think of something, just pop it into there. Whoever's not presenting will be taking those questions and answering them in the panel. We'll take some of them and we'll answer them live. If there's one that you specifically want us to ask live to whoever's presenting, you can indicate so. But yeah, so just there's no stupid questions. Just ask a question when you think of it, and we'll answer it, and we will stay. We'll stay for as long as we can, and hopefully we'll answer all of the questions. But it's a demo, right? So things, we're going to demo, we're going to show you some stuff. It might break. If it does, don't worry about it. We'll figure it out. This used to be something that was really popular in the early days of doing lots of meetups. So people would get on Twitter and they'd tweet with the hashtag for Rancher Meetup, and I just went and looked, and nobody really does it anymore. But if you want to buck the trend, tweet about it. Say that you're here and use the hashtag Rancher Meetup. I will definitely delete that slide next time. This is the slide I expected, which is if you have to leave, or if you don't get your question answered, or the thing about questions is it's important to keep them on topic. So it needs to be relevant to what we're talking about today. So there might be questions that we don't answer simply because we don't have access to your environment. They're too specific, they're troubleshooting oriented, or they're just off topic. Slack is the place where you can go. If you're not a member of the Slack community yet, you can get an invitation from slack.rancher.io. It's easy to join. There's tens of thousands of people registered and thousands of people online, and all of them want to help you be successful. We have a lot of stuff to go through today. This is the part where I'm going to drop off, but we have a GitOps and Rancher continuous delivery introduction, followed by a delicious main course of a live demo, followed by a dessert of Q&A. And actually, the Q&A part will happen all throughout. As the presenters are presenting or doing demos, they'll pause periodically and ask us any questions. So that's another reason. Most wants me to play piano in the middle of the meetup. Talking about the keyboard behind me. No. I can sing for you though. Yeah, so like I said, ask your questions and we will dive in. And I think this is the part where who am I handing this off to?
To me.
All right.
So we're here to talk about GitOps and Rancher CD. Rancher CD is a new feature in Rancher 2.5 that you can take advantage of. We're really excited about it, and we'll try and get through the slides pretty quick because the demos are, I think, we're really going to shine. So yeah, let's take a quick second to define what GitOps is before we start talking about all of this. And so in kind of recently, GitOps is really used to describe an infrastructure as code practice, which basically boils down to you define your infrastructure in source files, like declarative syntax. So if you're using like an Ansible or a Terraform, that's certainly an implementation as well. In the case of Kubernetes, it's our Helm, our Kustomize, and our just raw manifest files. You commit those to Git repos. The benefits of doing that is that you have the pull request policy, right, or workflow, sorry. And with that, you're able to have PRs and review and see changes. You can go back in history, look and see what's going on. It just gives you a nice audit trail of all the changes that are happening in your environment. And so in the case of Kubernetes now, there's a GitOps engine looking at those source repos for changes, and then it pulls them down as they're made and renders them out into Kubernetes manifests and safely applies them in one way or another onto your clusters. Ultimately, this deploys your applications, it deploys your configuration, it deploys it's a great way to have a repeatable process to build out and configure your clusters. And so today, let's talk about what is Rancher Continuous Delivery. And so we've built a GitOps engine, and we've packaged it directly into Rancher. It's powered by our open source project Fleet, but we've really integrated it into Rancher so that every cluster you add is automatically now added to this our continuous delivery engine, and you can control which you can group your clusters together, and you can control which groups they belong to based on labels on the clusters. So as you add clusters and provision clusters, you're able to organize them into collections based on metadata that you're applying to them that makes sense for whatever your deployment strategy is. And so this really makes it simple out of the box. You're ready to go and just basically start pointing at a Git repo to start deploying manifests to Kubernetes. And so it's really powerful. And so the approach that we've taken, as I said, we've put Fleet, and architecturally, in the Rancher management control plane, it's a Kubernetes cluster where the Rancher servers are running, but we've also got the Fleet engine built into it, and it's watching Git repositories. When it sees these changes, it creates these deployments, the deployment bundles that go down to the downstream clusters. And so the benefit of this architecture is that it gives you a staged checkout. So it gives you kind of a two-stage method where it's pulling and then applying. And so it gives you the ability to centralize your RBAC and control how things are rolled out. This is also all based on a pull model. So each downstream cluster connects in and then pulls for changes, which we believe is much more scalable. The Fleet engine is designed to be able to power everything from GitOps on a single cluster up to 1 million clusters. And so we believe this architecture really scales, and the whole piece of it is really key to that architecture. This also gives us the ability to orchestrate the downstream rollouts. In some other architectures, you can have one repo to one cluster type of model, and with that, you basically have to orchestrate a rollout across multiple clusters yourself through some other process that sits on top of your Git updates. It gives you a lot of. It's a simple model, but when you're dealing with tens or hundreds or thousands of clusters, that becomes a little bit cumbersome. If you were to try and tie one repo to many clusters, you don't get the ability. As soon as you commit something, it's going to blast out to all of the clusters, which isn't necessarily what you're looking to do either. And then in some other architectures, there's it reaches out to all the downstream clusters. In those cases, the push model that presents challenges as it scales up, just dealing with network firewall rules, and it just becomes a bit of a logistical, an operational challenge when you're dealing with complex networks. So we really like this architecture. It's very similar to the way Rancher agents in the downstream clusters attached today. And when it's built into Rancher, and why Rancher CD versus just Fleet, we've got the management UI built into 2.5, and then every cluster is just automatically registered. So it's just available to you out of the box. And so when we get started with Rancher CD, you can just pick something small, like any config management system that you've picked up over the last 10, 15, 20 years. You start with a single task, and you kind of work it end to end, and then you just build up from there. And so what that looks like is you have your app, you've got a Fleet YAML maybe that you're going to describe how this application is being deployed. You have your simple Kubernetes manifest. You commit that app to your GitHub repo. Rancher CD detects those changes. It renders a target deployment, and then pushes that out to the dev cluster. And this is just a nice simple end-to-end flow. And they can get much more complicated and flexible, and we'll go into some of those knobs here in the slides, and then Gar will really dive into it with applications and demo. So you have two main things to map out when you're dealing with your Git repository. So you have your source code, which is, this is a file structure on the left here. It can have multiple directories, different paths, and each fleet.yaml file becomes a deployment bundle, if you will. And so you can have multiple in a single repo, and then when you add them, you have flexibility over which one. Add them to Rancher CD, you have flexibility to pick different ones. So if you have a centralized repo, there's a lot of your operational type of modules. You can map those in Rancher Continuous Delivery by creating a Git repo, and then in this path section, you pick which directories you want traversed in order to find all the bundles. And so you can get very specific. So I can install just the Rancher monitoring CRDs by specifying just that one path, or I can install everything under the Rancher, all the bundles that under Rancher, and Rancher CD will just traverse and find all the fleet YAMLs, create those deployments, and apply them to the clusters based on my targets. And so this is the main mapping of Git repositories to targets and the modules. And so this is a key thing to understand, because you have the source code repository, which the developers or your application owners might have access to that particular repo. You can have many. You don't need to just have one, but they have access to that through infrastructure as code in the Git model. And then you have an administrator or an operator that actually creates the mapping, right? It adds the repo, adds the specific paths, and it adds the target. So where it controls where anything in this repo can deploy to. And you can even get down into deeper levels with the agents and with more advanced RBAC as well as to how that gets deployed in the downstream clusters. But this is a key concept to make sure we understand. But the main source code to cluster mapping and modules or bundles is the main integration point. And so in the repo, we have this fleet YAML, and what this is it describes the way you want to have things deployed out into the cluster. And so this is a simple one that installs the Rancher backup utility and configures that for setting up backups in Rancher. Anything that installs CRDs or creates a namespace needs to have this default namespace. There's the Helm chart that we're going to be deploying, and so this we can specify Helm. If there's a manifest directory, it'll automatically deploy out of that, and then there's ways to describe Kustomize. Additionally, what's not specified here is you can actually pick out the individual targets that you want. So if there's a select based on selectors, so you can say any cluster with dev only has one replica, or any production one has 10 replicas and persistent storage. So you can get very flexible and override the values depending on the downstream cluster that you're trying to deploy to. And so then the next concept is so you've got the way you've described your bundles, you've got the mapping of your Git repositories to the downstream clusters. You now can specify everything from a single cluster to a cluster group, and this is where it gets really powerful. This grouping concept and being able to label and provision and have them automatically join this, it really can help you address use cases where you're like, I need to make sure Rancher monitoring is turned on to every production cluster, and so you can specify env prod, for instance, and so create a cluster group that maps to your Git repo with the way that you want to configure monitoring for your downstream clusters. And every cluster that gets added with that label will automatically have Rancher monitoring enabled as you specified. So it becomes really, out of the box config management for your Kubernetes clusters. And then as you add, from an operator standpoint, all of the applications you want to deploy operationally, and then you can add for your application owners ways to, the similar type mapping. So if they need to roll out to multiple clusters, you can, app is whatever, and that's the group of clusters they can deploy to. So this is very flexible and very powerful, and especially the grouping mechanism really helps it scale up more, because as you're dealing with more and more clusters, you don't necessarily want to deal with them individually anymore. You want to manage them, either regionally or by some group. Okay. So before we jump to the demo, are there any questions we should take right now?
Yes, there are. First of all, Andrew says that was a good explanation and very helpful. Thank you for that. So Mosin is asking about the architecture behind Rancher CD. Is it just a container? Is it an operator? How is it designed? And then is it standard in 2.5?
It's built into Rancher 2.5. It's enabled by default. So out of the box, it's a operator controller, however you want to describe it, that runs in the Rancher control plane Kubernetes cluster. So the same one that's running Rancher server also runs the Rancher CD controllers. They'll be in the fleet namespace. Then every downstream cluster has an agent that's deployed to it that connects back into the fleet controller and is able to interact with those clusters. And so all of that registration and is handled for you out of the box. And so the only thing as an end user or operator that you need to pick up is, create source repos and start mapping them to your downstream clusters.
Okay. Ronald says, I have dependencies between different repos. How do I ensure that they're deployed in the appropriate order? And he gives an example of, I need my monitoring repo with a Prometheus operator CRD and custom resource and a service monitor and another repo. Is there a way to make sure that those go in sequentially?
I can sort of take that one. Yep. I don't really think you need to worry about it too much, because you let Kubernetes do the heavy lifting. For example, when it tries to apply the CR before the CRD exists, it'll error out and it'll sort of enter an exponential back-off loop, and it'll keep retrying until the CRD exists. So eventually, you will get to the eventual state where the CRD and the CR both get applied.
Perfect answer. Eventual consistency. Great. Yep. An asks, and I don't know if we can answer to this, do you have any thoughts on how this compares to Flux? Like, does it do some things differently or better, or without turning this into a promotional thing, can you speak objectively about that?
Yeah, so Flux is, was the original. It lines up with it follows a model of one cluster, one repo. Today, I mean, they might be addressing this. And so in that model, it manages deploying and configuring a single cluster. We're in the space of this, and so when we looked at GitOps engines and whether we should use one off that exists, or if we need one to or if we need to build one, what we looked at and saw was that when we're deploying to, our ultimate end goal is to deploy to hundreds of thousands, millions of million clusters. And so what we saw, none of them really had that design goal in mind when they set out. And so we believe that Fleet, as an engine is the GitOps engine we believe will go to that scale that we need. And then integrating it directly into Rancher and making it easy to use, because there's a need both for the edge use case of all of these small devices running Kubernetes, and then the data center use case also. There's a lot of overlap there, and so we're even down to a single cluster. We're able to leverage this engine. So Flux and Argo CD are obvious competitors to this. Each of those that has a different approach to it. Argo adds workflows on top of it, which does have some nice dependency management and some interesting hooks types of capability. But when we looked at them from a scaling perspective, they currently use a push model, which from what we've seen and where Rancher is deployed, that that wouldn't scale to the size or operationally be convenient for the users that we have.
A well thought out answer. Thank you. We have 2 more questions, and they're all, well, 3 questions. I love that. We're almost out of questions, and then suddenly the questions start coming in. Okay, so these 2 questions are similar. I'll read them both, but I think that they have the same answer, and if not, then you can just tell me I'm wrong. Svelin wants to know if there's some sort of approval before continuous delivery kicks in, and Ashish wants to know how Docker images and config versions are managed prior to the CD component.
So Git is your authoritative source. I mean, kind of answered, they're somewhat related. So the Git repo is the authoritative source for all things being deployed to the cluster. So you have to be very explicit. You see a very explicit who changed what. So as far as approval process, that would probably, right today, that would fall to a PR being made, a user saying, okay, I'm merging that PR. That would be your approval to deploy, because that would immediately start the process to deliver that application. You have some, and so yeah, and then as part of that deployment, you would define all of the versions, all of the values, everything that you want deployed on that application. You have a very flexible, kube control apply. So by the time you do that, you know everything there is to know about what you're going to deploy.
Let's go. Let me just skim these questions really quick. My favorite part of this is I ask you a question, you answer it. I don't listen to you because I'm reading other questions.
Right.
Does this have any support for canary builds or incremental deployments? That's a question from Lou.
Garv, do you have any thoughts?
So, well, you could use like any traditional canary release process. Like I think we also looked at the Weaveworks project, forgot the name, to do canary releases, but eventually, to do a canary release, you just sort of, update the manifest or instruct the Kubernetes cluster to perform some changes for the canary release, and that can be managed through manifests, which in turn are managed by, say, continuous delivery. And all it's doing is polling your Git repos for updates to those manifests and pushing them to the downstream clusters. So basically, you could use whatever you're using right now, like any existing method you're using for canary releases. You should be able to plug it back into leveraging that with continuous delivery too.
Okay. Anna has a follow-up question. Would like to know if this uses Cluster API behind the scenes so that it's portable across IaaS providers.
So they have very separate concerns, but Rancher CD delivers Kubernetes manifests, so it's compatible with Cluster API. If you wanted to create clusters through Kubernetes manifest, you could use Fleet to deliver those.
Okay. Oh my gosh, so many questions rolling in. Let's
just a caveat.
Let's go through. Go ahead.
I want to keep that answer though. It's compatible with like Fleet being able to deliver the binaries. That does not. Rancher itself is not. That doesn't automatically register back into Rancher, and there's no direct integration today with Cluster API.
Okay. Ankit would like to know if I don't change the Git repo and I only update the Docker image, such as changing the tag, does Rancher CD have any feature that it will continuously pull Docker registry like Flux does and update the pod with the latest image?
No, it does not have that today.
Okay. The other part of my job over here is to type the answers to your questions as you say them. Pierre says, will this lead to Rancher itself being more manageable with GitOps methodologies?
Yeah.
Yes.
I mean, that's a goal of ours to be able to configure, Rancher itself and all of its tooling, through GitOps methodologies. It's a long-term. It'll take us a while to get there, but it is where we hope to get to.
Okay. Let's move on to demo, and perhaps Bill, you could answer some of these questions in text, and because Gaurav's doing the demo, right?
Correct.
Okay. Yeah. So and then because there's some questions rolling in, but I want to make sure that we get to the demo stuff, and there's going to be a lot more questions, and then we can come back and start to hit these as appropriate. Okay. So Gaurav, I will make you the presenter. Okay, we can see your screen. Take it away, my friend.
All right. So this is Rancher 2.5. This I'm running 2.5.2, the stable build, which came out yesterday. Depends where you live. And you can get into continuous delivery either from, by just going under the tools section, or if you are already in the cluster explorer, then we can access continuous delivery from there as well. So we can see it's available here too. So I'll quickly go over some of the core concepts that you sort of need to be aware of when we sort of start using continuous delivery. So first up is clusters. As you can see, Rancher already takes care of the heavy lifting for you by automatically registering all the clusters managed by Rancher with continuous delivery. Then we have cluster groups, where we can basically organize clusters into groups based on labels on the clusters. We obviously have the Git repos, where we sort of set up our repos, the paths, and then map those repos to individual clusters or cluster groups. Apart from this, one quick thing I wanted to highlight was the sort of the workspaces here. So there are a few workspaces. So one is the fleet default, where you'll see all the clusters being managed by Rancher available, and then you have fleet local, which is for the local cluster. So if you wanted to use GitOps based approach to sort of manage, or continuous delivery to manage the cluster where Rancher itself is installed, then we need to make sure we use the fleet local workspace, and we'll see it in action shortly in the demo, how it makes sort of management of Rancher itself a lot more easier. All right, so we'll dive in straight to sort of deploying an app. So before we do that, I'll show you how you would sort of traditionally deploy apps with the new Rancher apps. So for example, if you have a cluster where you wish to sort of install something like monitoring, right, you would have to go to that specific cluster, and you would sort of follow a traditional approach to sort of actually deploy the component to that cluster. With 2.5, we have sort of packaged all the components as Helm charts, which makes it even easier to consume these via continuous delivery. And we'll shortly see this in action. So if I have to install monitoring to a cluster, I would have to sort of come in here and basically click start monitoring, which can get sort of cumbersome to manage if you have lots of clusters, and especially if you're running thousands of small clusters, it can become sort of cumbersome to make sure all the clusters are in sync. So we will ignore this and go back to continuous delivery to see how we can fast track this. Right. So I will create a cluster group to start off with, and I'll call this cluster group called monitoring. And this is, the group of clusters where I wish to roll out the sort of the Prometheus stack. And again, this is similar to what Bill mentioned in the slide deck, that we sort of can use this grouping model to roll out, say, monitoring, logging capability to all your production clusters, for example. So I'll create this group. Right now, it says there are no clusters that match this group, which is fine. So now I can go to clusters and actually assign them, to groups. And this basically runs off labels on the cluster objects. So I can edit it as a form, and I can add a label. Similarly, I'll apply this as well. So now if we go back to my cluster groups, now we can see, I've got a monitoring cluster group, and now it's got 2 clusters, and they are becoming ready, just sort of reconciling. While we wait for this, I'll go and set up my Git repos. So before this sort of, meetup, I took the time to sort of set up all the core sort of, utilities that you can install via Rancher, let's say the monitoring, logging, CIS benchmarking, Istio, into our fleet bundles. So, the manifests. So for example, these are the 2, folders I need to apply into the monitoring cluster group. So this contains the CRDs, very straightforward. I have, this is the namespace. This is the chart for the CRDs, the repo for the CRDs to get it going. And then obviously the actual Prometheus operator as well. So as you can see, I'm deploying the Prometheus operator into this namespace, and I'm also customizing it. So for some of my demos, I want to roll out Loki as a log aggregator on my clusters. So I'm already going to add an additional data source for Grafana to consume that stack. And you may see this additional logic, for the diff. You can go through our docs and, understand it a bit better, but this is for use cases where your Helm chart does certain things in a way where it's creating some objects or changing some objects which aren't really sort of, clear in terms of the reconciliation logic. So we allow, a fleet to ignore some of those delta changes, so it can sort of, still reconcile the state of the charts it's deployed properly. And that would be like a really short way of explaining it, but it sort of is a bit more complicated. It's basically like a JSON pointer patch that you can write and instruct fleet to ignore certain changes on your workload. So back here, I'll deploy monitoring. So I will point. So now I can add the paths. The monitoring CRD and monitoring. And now we can select the, the targets for this. So we can either select individual clusters, or we can actually select a cluster group. So we'll select a cluster group to get this started. And I will just click create, and we can see it'll just quickly reconcile the Git repo, and then, identify the clusters where it needs to be applied. And then it'll start rolling out those packages to those clusters. So you can see it's detected that there are 2 clusters that need to have these packages. If I go to the bundle section, we should be able to see the actual workloads being deployed. So again, this comes back to one of the questions that was asked, that you have a CRD in a separate repo from the actual objects for that CRD. So this is similar to that. So if you were to go look at the monitoring one, the first time it would have failed because, the CRDs didn't exist, and, eventually the eventual consistency would have kicked in and it would have retried, and then would have been able to create the remaining objects as well. So cluster groups are really powerful, because as you can see, I'm suddenly rolling out the monitoring stack to a couple of clusters. So, if I want to add more clusters that need to have monitoring, pretty easy to do. I can also assign them directly from here. So I can say monitoring enabled. Yep. So those errors are for the initial reconcile logic, where it needs the CRDs to exist before the actual CRs are applied. It will eventually reconcile. And monitoring will get rolled out to those clusters. So if I go back to the repos, I should be able to see additional clusters getting the monitoring rolled out to them. So it should take a few more minutes for the actual monitoring capability to be rolled out to your clusters. So if I were to, let's see which clusters actually have all. So the DigitalOcean has it set up. So if I were to go back to the cluster explorer, I should be able to see the monitoring installed here. And you can consume it as you would. So again, makes the life cycle management of your clusters really easy. You can manage them, the state of your clusters using Git repos. Similarly, I'll create another repo to sort of deploy logging. And we can add the repo. So now I shall target the logging cluster group. So obviously I don't have any clusters in this group, so I'll just assign some of these clusters. So here we go. Oops. Should have it. Also assign this to So now we can see we have a few clusters in the logging cluster group as well. And now logging is getting rolled out to all of your clusters as well. So again, it'll eventually reconcile. It'll sort of error out while it waits for the CRDs to be applied, and then it'll retry creating the objects, the CRs based on those CRDs. And in a few minutes, we should have monitoring logging rolled out to all your clusters. So, or sorry, the ones we targeted based on the cluster groups. So yeah, I mean, in this particular case, I actually sort of targeted the deployment to specific clusters. If needed, you can sort of use the default, which is to roll out the particular object that you wish to all the clusters in the cluster group, and that's pretty useful as well. So while we wait for the workloads to get deployed, are there any questions before I move to the next phase?
There are so many questions.
Okay.
Okay, so Morton asks if we have any best practices on how to handle secrets with Fleet.
You're going to say something, Bill?
No.
At the moment, I mean, that would be a challenge in terms of how you push out the secrets, because eventually you need to inject the secrets someplace. One of the easiest options, that would work with something like continuous delivery would be to use something like the Vault, backend for Kubernetes to inject your secrets into your workloads, and obviously that runs off annotations which would be on the actual manifest or on your actual spec. So that would be one way of handling it.
Okay. XYZ wants to know if Rancher CD supports variable interpolation in the different manifests, like the YAML, Kustomize, Helm, etc.
Yeah, so in the Fleet YAML, you can apply updates. So for example, if you look at my the monitoring package that I have, or the monitoring bundle that I have, I am sort of updating the values. You can obviously do even more sort of fancy things like applying certain values or overriding certain values based on cluster groups or labels that it detects. So that can be done as well. And again, the same goes for customized templates as well. So we have a repo Rancher Fleet examples. If you go in here, you'll see lots of examples. So I'm pretty sure we have an example with Kustomize here, where we are sort of using, we are doing targeted customizations and then, applying overlays, based on the particular target. So again, Fleet is very flexible. Yeah, and it even allows you to combine stuff like Helm and Kustomize. So for example, we'll have an example here. We are using a Helm chart, but we wish to sort of, apply some customizations using, say, Kustomize. So we can do that as well.
Nice. That's perfectly timed because Ronald just posted out a question, but he said often Helm charts require the use of Kustomize to take care of the last mile. So there you go.
Yep.
All right. Perfect. We have a couple of customized questions here. So
sure.
Hang on a second, because I'm typing, listening, and scrolling. Where was it? Ronald wants to know, what's the best way to apply patches for individual cluster groups using Kustomize?
So, I mean, I believe this would be one of the examples, right? For example, we have a target customization, and I'm saying, so for the cluster selector where, the label is this on the cluster, then apply this particular customization. So for example, a cluster would have the label env test, get, this customization overlay applied. So it's, again, this example has all the combinations you could think of. Plus, if you go,
and now his other question makes sense now. His other question was an extension of his first question. So yeah, so
sure. Yep.
I just asked this question twice. Okay, moving on. Marco wants to know, how do you manage Fleet workspaces?
So by default, we'll create two workspaces. One is Fleet default, where all the clusters get registered, and then there's Fleet local, where the local cluster gets registered. For most use cases, those should be enough. They are automatically created for you. And on the Kubernetes side, which is the local cluster where Rancher is installed, those are two namespaces. So further in the demo, we'll launch a Rancher sort of instance and bootstrap it using, Fleet, and it'll sort of become sort of more clearer how you can leverage both the workspaces to sort of, maintain the entire life cycle of your Rancher cluster. Yeah.
Say no more. Say no more. Leave it. No spoilers. No spoilers.
Sure.
All right. Subhash wants to know, once Rancher 2.5 is installed, are there any additional configs that need to be run on each Kubernetes cluster before you can start using it with Fleet?
No. So, I mean, if you're already using Rancher and you upgrade to 2.5, then we will automatically register your existing clusters into Fleet. And once you are on 2.5, any new clusters you launch will also get registered into Fleet or continuous delivery. And that's where, the value proposition is, the ease of sort of registration. So from an end user perspective, just launch the cluster and let us do all the heavy lifting for you.
Interesting. Okay. These next two questions then may tie into that. Rory wants to know, is there a way to automatically add future clusters to specific groups, like monitoring and logging, and like a policy mechanism to ensure consistency?
Yep, we can, and that's the entire reason for cluster groups, and I will show that shortly. That's
No
part of the demo as well.
No, no more. Okay, Eric wants to know, can the cluster assignments be handled in a Git repo instead of using the GUI?
In terms of assigning the clusters to specific cluster groups via Git repo,
perhaps.
I think that's where we want to head to with subsequent versions of the product, like a core product, the ability to sort of manage your cluster objects natively as Kubernetes YAML manifests. Right now, the best we can do is to sort of create cluster groups via a Git manifest, and then sort of assign clusters to it, and that cluster assignment can be done as part of the cluster provisioning. So for example, if you're using something like Terraform, right, the assignment of clusters to groups is based on labels. So you could automatically add additional labels on the cluster, and once the cluster is provisioned, it automatically gets into the correct group. And once it's in the correct group, all the applications that need to go to that cluster get rolled out to it.
Okay. In your upcoming demo, will you show any type of upgrades? Because there's a question about upgrading logging, but I'm not going to ask it if you're going to show it.
Let me see. So, I mean, we can do upgrades as well, because eventually it's just using Helm to perform a rollout of the application. So I will roll out some sample apps, and then we'll do an upgrade of those apps as well using like a traditional Git flow. I think if it's specifically about deploying, I see a question about deploying the elk logging. Then again, if there is a Helm chart, you can leverage continuous delivery to sort of package that Helm chart into a Git repo, and then use cluster groups to roll it out to as many clusters as you wish to.
Okay. All right, last question for now, and we'll let you get back to your demo, because I see everything is active there.
Yeah.
We have a question. Santa Kumar would like to know how to deploy elk logging at namespace level and not at the cluster level. Is that was one of the things I wasn't paying attention to for your demo.
What I was trying to
correlates to something that you showed.
We can deploy. So again, that's a very specific use case where you want to deploy elk to a particular namespace. That would be just a Helm chart to deploy elk into a namespace and then make it available only for that namespace using the traditional logging. That's more of a logging question. I mean, I can take it up if you want, but we'll deploy something like Loki, and that sort of tries to accomplish the same thing as well. So hopefully that.
So that's not part of this continuous delivery functionality. That would just be handled by I want to just deploy Helm or deploy with Helm.
Yeah, if you have if you can package up your manifest or whatever you use to consume Kubernetes into a Git repo, you can definitely deploy a full logging stack as well. So Rancher logging provides you the way to ship the logs to an endpoint, right? But we don't have an endpoint right now. I will deploy an endpoint shortly, and then I'll deploy some workloads to consume that endpoint and tie it all together. And that's where we feel we can add value, and continuous delivery can add value as well.
Wonderful. That sounds like a great time to let you continue with your demo.
Cool. So as you can see, we've got monitoring, logging all running. I'll quickly deploy, an actual log aggregator, log aggregation stack as well. So I'll deploy Loki. I have a repo for this. And I'm going to say, I'm just making sure. Yes, so Loki, and again, I wish to deploy to sort of, all to the logging cluster group, because I already have the logging, tooling deployed there to actually ship the logs for me. So I'll deploy this. I can actually show what's going on under the hood as well. So this is the simple, chart for Loki. And I'm again, the chart does certain things which needs me to patch it to allow Fleet to reconcile the state. So now, yeah, so in a few more seconds, hopefully, Loki should be rolled out to all the clusters which have the the logging, lib, which are part of the logging cluster group. I'll just make sure I have, yep. Just making sure, because I need to use this to actually now deploy an app and consume that log aggregation layer as well.
While we're waiting, do you want to explain a little bit more about Loki?
Yep, so Loki is like a simple log aggregation stack similar to Elk, but like a lot simpler, has less requirements. It was like one of the easiest to set up. And to consume Loki, you can use Grafana so we'll quickly jump in there. So I shall go to my dev cluster where I have actually deployed Loki. So if I go to monitoring, the way to browse the logs in Loki is to use Grafana, and in here I can sign in. Oops. Right. So in here I should be able to explore, and you can explore metrics on Prometheus, or you can just search for metrics or queries. It's similar to Prometheus but for logs, and then you can use Grafana to visualize those logs. So in this particular case, I've actually deployed a logging stack, which is easy to sort of set up, single container image. And again, back to the original example where I was setting up the spec, I've already configured the data source within Grafana when I deployed monitoring. So yeah, I hope that helps. So the idea being, now when I deploy an application and I start consuming that application, with my application, I'll also be deploying, a log output and a log flow, which will sort of ship the logs for that particular application into Loki, and then I can use Grafana to sort of search those logs quickly. Yep. So that's that. So this sort of till now we've seen how to deploy, let's say the infrastructure side of the services. Now we'll just sort of use traditional GitOps approaches to roll out application to your clusters. For example, we've got the clusters ready, so we'll set up some apps. So I have a demo app, and this is for the dev one. Let me check. It's Fleet. Simple app. And actually, I forgot to create the cluster groups. Sorry. So I will create cluster groups first. So I will create a cluster group for dev. And again, this helps me, target clusters more effectively. This is pretty useful for use cases, again, where you have a large number of dev teams who are consuming lots of Kubernetes clusters. So you can just, assign the clusters to the correct cluster group, and we roll out the correct version of the app to that, to that set of clusters. And I'll create a prod one. All right, so I'll assign the clusters as well. All right, now I can create my repos here. And I will specify a particular branch, and I will be targeting the. So my setup is the dev branch targets the dev cluster group, and I need to add a path. So this is my simple app, a very standard app, which instruments a standard API, a web server with some Prometheus metrics, and my manifests are available here. So I'm creating a service monitor to scrape those metrics, and I'm also creating the logging manifest to sort of, to leverage the logging stack we have on those clusters to create the output and the flow. So all my logs for this app get shipped to Loki. So all right, and so that's like the dev version of the app done. I will quickly create test and prod as well.
Does Rancher CD work with private GitHub repos?
Well, technically, Rancher CD, you should be able to use Rancher CD with private repos as well, because you can specify your credentials here. If you have it again, yep.
Look at that. I love asking questions at the exact right, perfect moment. It makes it look like I know what I'm doing.
And that's perfect. So this is my test app to target the test cluster group. And I'll create a prod one as well.
Hey, Bill, you still around?
Yeah, still here.
So while Gaurav is putting all this together, there's a question about if Rancher is putting together anything with OpenTelemetry, Grafana Loki, any kind of tracing functionality. Is there anything you can talk about that?
Yeah, it's something we think about, but we don't currently have a plan for rolling out those tools. When it comes to 2.5 and our Istio, our new Istio integration, we're adding back in Jaeger at some point, or we have the intention to add that back in. So you would have that kind of through Istio, but yeah, outside of that, not at the moment.
Okay. The end. Enough said.
Mm-hmm. ...
So yeah, so my apps are now deployed to these clusters. So if I actually go to my dev cluster and look at the cluster explorer, I should be able to see my app in here. And I've also created, the logging objects. So apart from deploying the app, as my manifests mentioned, I have created a service monitor for my app. So Prometheus can scrape the metrics for my app, and I can sort of, eventually create visualizations in Grafana. And if I go to logging, I have also created the flows. So for example, here's the output, which sort of, consumes Loki. And then I have the flow, which ships those logs to the particular output I configured. So now back to more of the traditional sort of, GitOps approach. So for example, I'll go back to deployments, and I will quickly create a pull request just to sort of show the end-to-end flow of what you would do in a traditional GitOps sort of approach. I am going to roll out a new version of the app. Yep, so the changes are there. So now we can go in and create a pull request as you would do to sort of, roll out your changes. So I'm going to merge release to dev. I'm going to follow a traditional CI, the CD process, get to dev, then test and prod. So again, so this is where, you would have some sort of approval process. I remember there was a question around this when we started. So this is where you would sort of, add the gates to control what gets deployed and how the approval works. Yep, so I have a pull, my pull is complete. And if we go to Fleet, Fleet should detect that there is a new commit available for the dev branch, and then it will start rolling out the application to all the clusters that are part of the dev cluster group. So yeah, so you can see it's the hash has changed, and it should, and here we go. It started rolling out the update to all the clusters that make up the dev cluster group. In this particular case, we just have one, but obviously, we can add more. And if I were to refresh this, I should see the new version of the app, the V2 app deployed here. So that would be like a traditional flow. I'll sort of now create another pull request. So I'm gonna merge dev into test to roll out my changes to test as well. And we should see, continuous delivery, detect the change in the Git repo, and then eventually rolling out V2 of the app to the test cluster group. A few more seconds. Yep, okay, here we go. All right, so we've rolled it out to test, and we'll merge it to master now to roll out the new app to production. All right, should take a few more seconds for prod to detect the same, and it'll get rolled out. I realize now that I had named the Git repo just prod and not demo app prod, but that's okay if it upsets anyone. I'm truly sorry.
That's all right. It's all right. It's a meetup. It's a move fast and don't break anything kind of day.
Well, I mean, if it hurts someone's OCD tendencies, it's not sort of following the correct convention, then I'm truly sorry.
It'll be okay.
Yeah. So yeah, so this is like a standard rollout of the app across. So you can see like you would do with the traditional GitOps approach, where again continuous delivery really shines is now rolling out all these apps when a new cluster pops up. So for example, I already have a K3s cluster around. Let me just make sure. Just making sure it's still up. So dev2 is the name of this cluster. So again, I can just add the labels right here and they will get, propagated down into continuous delivery. So I can say environment type dev. I want to roll out monitoring, and I would like to enable logging as well. So this is what I was referring earlier in the conversation, that you could use Terraform when you create the clusters. You could sort of, add the labels and they will, allow the clusters after it registers to get into the correct cluster groups, which subsequently allow all the apps to be targeted to those clusters. So because of these labels, as soon as I import this cluster and it sort of registers with continuous delivery, we will deploy the monitoring, logging, and the dev version of the app to this cluster, again, which makes management of lots of your clusters or the state of your clusters really easy. So I will just import this. All right. So should take a couple of minutes for the registration process to complete, and then all the applications will get rolled out to the new cluster as soon as it's sort of available. So while we wait for that, I'm happy to take any questions if you have any before we move to the next step of tying all of this together using more sort of infrastructure as code practices.
There's questions.
Sure.
I try to figure out some of them on my own.
Okay.
Somebody asked
Well,
if
let's go.
Rancher logging notifier supports logarithm, and I was like, I don't know, like I'm trying to find out the Bonsai Cloud logging operator, but it'll talk to stuff. Anyway, that's not a real question. Or at least that's not a question I'm asking you. That's a question I was trying to figure out when you put me on the spot. Let's see. A while ago, Murali asked if it's possible to send mail alerts for the monitoring or if you need to watch it in the UI. I don't know if that was related to something that you were talking about or if that was just like a general Rancher monitoring question. So if it's not relevant, you can.
I think it's more of a general monitoring question, nothing to do with I've done. I mean, obviously, you can manage it all using continuous delivery as sort of, manifests and roll it out at scale to all your clusters if it helps.
Okay.
So before we jump into the next question, my dev2 cluster is registered. And if I go to continuous delivery, you can see all the workloads getting rolled out to the new cluster that's just popped up.
Yeah, cool. Krzysztof says, from what I see in the fleet YAMLs, you have to specify the URL of the Helm chart and the values to supply it with during deployment. And he asks, do you support more advanced Helm command line switches like set file to populate a config map with a file that's also in the same repo, or any interesting patterns like that?
We don't today, but that's a good feature request. I think would be something interesting for us to look at. So if they want to open up, if they can open up an issue, we can take a look at that.
Got it. Krzysztof, please open an issue. We like cool features. Ronald says, Ronald says, it's funny. Ronald says, in the Helm customized example that was shown, is the customized Helm chart transformed back into a Helm artifact before being applied to the cluster?
Yes.
Yes.
Good.
Yeah. So basically, the GitOps, well, continuous delivery will take the Helm chart, apply the customized template, and then publish the eventual result as a Helm chart, which gets rolled down to the downstream cluster, or rather the downstream cluster sort of polls that and applies it once it's available. You can actually see if you dive into the bundles, you can actually sort of see the actual sort of rendered manifest here. It will pop up. So this is what it looks like, and this is the actual content again, which if you have a customized template to patch on top of the Helm chart, it will show up here, and you'll see what's actually getting rolled out to the downstream cluster.
And you can also now see them on the downstream cluster in the apps catalog under the installed apps section.
Yep. So right here.
Oh, that's great. That was the second part of his question, was if the applied bundles appear as Helm installs on the target cluster.
Yep. You can see all of them here. Nice. So this is the dev cluster. You see my demo app, Loki, logging, monitoring, everything's here.
Cool. Santa Kumar asks how to deploy to multiple target namespaces in the selection.
I mean, for right now, the fleet YAML only allows you to target one namespace, not multiple namespaces. If you have a requirement to target multiple namespaces, I would say, create multiple folders in your in your repo, and then have multiple fleet YAMLs pointing to different namespaces to deploy the same app into different namespaces. That would be the only way that you could do it right now, as of today.
Interesting. So so you can't even deploy to different namespaces in different clusters. There has to be the same namespace in all of the clusters in the group.
Yep, that's right.
Okay, so that's different. That's different from how the Rancher multi-cluster apps worked, where you could just select arbitrary namespaces.
I thought in multi-cluster apps it was by project.
Yeah.
Was it by project?
Yeah, so you could pick arbitrary.
Okay, it was a project. Okay.
But I think at the end of it, I mean, I guess if you were to like have targets, you could in the fleet YAML, you could probably specify if you made the namespace a variable in your Helm chart or your manifests, and you had the different targets, you could set that uniquely per.
By using the the value override here.
Yeah. And then you could, and then on, there's a target override, and then, but that would work for different clusters. That wouldn't, you would need a bundle per namespace to go onto the same cluster.
Sounds like the kind of thing that can also get confusing.
So we've seen this, how easy it is to add multiple clusters. I'm sorry to interrupt, because I just want to kick off the next bit where we sort of tie it all together, and then we can jump back into questions, because it'll take 5 minutes for it to bootstrap, if that's okay.
Rock and roll, take it away.
Sure. So we've seen how we sort of managed your clusters and the state of the workloads that get deployed to those clusters using continuous delivery. The last bit I wanted to showcase was how I think we could tie all of this together. So I have written this bootstrap script, which I will use with rancherd, and which is based off RKE2. And if you've used K3s or RKE2, you know that we have like an add-on controller which looks for manifest files dropped into a particular path. In this case, this is the path I'm looking for. And then I deploy this setup YAML. I basically write this file. And if you see carefully, I'm as part of this, the write-up of this file, I'm going to create, a backup repo, so I can install Rancher backup to the local cluster. Then I'm gonna again create multiple cluster groups: dev, test, prod. I'm gonna create a monitoring cluster group, a logging cluster group. I'm also going to create a Longhorn cluster group and CIS benchmark. Then we'll deploy monitoring, logging, the Loki stack that we just saw. And again, this will set up all the repos, the apps for those, that simple app that I deployed to multiple, cluster groups that we've targeted. And last but not least, I'll also kick off a backup. So I'll also do a backup creation. So the idea being, as soon as this ranches up, it's got all the apps ready to go. It's got the backup configured. The backup's already running. All you now need to do is import or add clusters with the correct labels. And within a few minutes, everything is up and running. So it'll take a few minutes to get started with. So that's why I wanted to sort of take this opportunity to kick this off while we answer questions. So I have a Terraform module here, which sort of bootstraps VM and injects certain custom cloud in it. I'll show that as well. And the custom cloud in it includes bootstrapping rancherd, and then also pulling this file from another Git repo to apply or set up the rancher for me as soon as it's sort of bootstrapped. So I'll quickly show the cloud init template I have as well. And then we can go back into questions, because it'll take, I think, a few minutes for it to boot up completely and apply all those manifests.
While this is going, should we do questions, or
Yep,
is this a good
we
time?
can do questions again, and it'll
Okay.
take a few minutes anyway. Yep.
Okay.
Typing a response to somebody's question. I wasn't paying attention.
Yeah, no worries.
Okay, you want to read some and I'll finish my response?
Sure, sounds good. Are the REST APIs available for deploying the workloads on CD programmatically?
I guess you could use the Rancher APIs, or you could just technically create the sort of the manifest, using kubectl apply on the local cluster, like I am doing here with rancherd.
Yeah, I think that's, yeah, since Fleet is a Kubernetes operator, the
Yep.
primary interface is Kubernetes, so you could use those APIs. There's also, I'm not sure. Yeah, that would be the way to do it, is to tie the Git repos. But there's a process we haven't documented yet that we're looking at, where you would be able to, you could have a stage where you render the bundles outside of Rancher and then apply the bundle, which Fleet would pick up and deploy.
Yep.
Given this new,
Yep.
Sorry, do you want to say something?
I just wanted to say my VM is up. We'll just give it a few minutes
Okay.
for rancherd server to bootstrap, and once it's up, we can then basically log in and see, the result of all the work we've done. Yeah, we can get back to the questions. Sorry.
Given this new method of deployment, how does one integrate CI/CD scanning via security apps into this delivery process?
Depends, right, how you're doing the scanning, because we aren't really building the artifact in this demo anyways. I would assume you are performing the container image scanning as part of the build pipeline.
Mm-hmm.
So that probably stays the same. I mean, if you wish to, or if you are scanning images, or you wish to scan images as part of the deployment pipeline, could be like some sort of webhook, which, I know some sort of, custom products do that. They sort of, expose a validating webhook which looks for deployment pod manifests coming through and then sort of extracts the container image name and scans that image before allowing the deployment to proceed. So again, if you are using one of those products, it would probably continue the same, because eventually we just talk to the API server and instruct it to do something, and the validating webhook would kick in, do its job, and either let the deployment go through or block it.
Cool. If I have a K8s cluster with Helm 2 installed, will Fleet adapt and publish that, or will it start creating Helm 3 releases from the Git repos?
Good point. I think when we create the release to go to the downstream cluster, which is applied by the Fleet agent, that's definitely Helm 3 only. I'm not sure if we would detect Helm 2 in the source project. I've not tried using the Helm 2 sort of repo for a while.
Yeah, I think, if I'm not mistaken, I think Helm 2 is officially life this quarter, I think.
Yeah. I hope that answers that question.
The answer is upgrade to Helm 3.
That's the easy way of putting it.
There's just so many benefits to using Helm 3 over Helm 2 that there's I can't think of a reason not to upgrade.
We have one more. Have the demos been conducted on RKE2 hardened clusters? I guess that means RKE2 or RKE government with the CIS profile enabled.
No, I'm only using K3s and our standard RKE clusters, EKS clusters, GKE clusters as part of the demo. For example, RancherD itself fires up RKE2 in the background, but again, I haven't used the CIS hardened profile.
Gaurav, can you share the GitHub repo that you used to build the vSphere cluster?
Yeah, sure. I'll clean it up. It's just got my public keys in the file. I'll put it. I'm not sure how to share it yet.
Post it in the chat. Just post a link to it in the chat. Maybe. I mean,
sure.
If it's not shareable, then obviously don't. But
yeah, right now it's. I'll put the link. Right now it's a private repo because it's got my public key in, even though it's a public key in the cloud in it. That's it. But if you have the link, you can come back to it and it'll be there for you. So
okay.
I forgot the name of the repo. Sorry, let me check.
No, that's okay. So
yeah, we're waiting for it to boot up anyway, so
okay. "90 minutes in, this is the portion of the meetup where we're all just starting to get a little tired.
Yeah, so this is the repo. So I'll put this in. I'll sort of open source it.
I can put it in the chat. Oh, you got it. Yeah. Perfect.
So I'll open source it, and it's pretty straightforward. It's just like a simple, and the secret sauce is in the Cloud Init template, which does all the heavy lifting. So you could use it with any cloud provider, and even the Cloud Init template eventually calls this shell script. I'll put this in. So this is what's actually doing all the heavy lifting in the background once the cluster boots up. So I hope that helps. Oops. So back to this. So I can see just making sure Rancher's up. It is, and I will do RancherD. And that will give me the URL and the password to access this newly installed Rancher. It's using the self-signed cert, so I'm going to ignore it. There is a document available which explains how to set this up properly with a proper cert if this is of interest to you. And I will quickly grab the password. Standard housekeeping, making it secure with the least secure password. And I shall log in. So now you can see my cluster is up. If I go to continuous delivery, so you can see in the Fleet default, all my repos are already set up, ready to go. All you need to do is add the clusters. So this is the default one. If I go to my local one, I have set up backup using continuous delivery on the local cluster where Rancher is running. And if I were to go to cluster manager, I sort of also, sorry, I needed the cluster explorer. I also deployed the local path provisioner and set up recurring backups. So here we go. I have deployed a local path provisioner, and I've also set up a backup schedule to back up my Rancher every day. So again, this is one way of bringing everything we've seen all together. And I really hope, it sort of helps people, gives them some ideas on how to sort of, leverage continuous delivery to sort of, maintain the state of all their workloads. Yep, and we can jump into any more questions if we have any more left.
There are no questions left. People are just speechless. There were a bunch of people that posted stuff saying thank you, saying awesome demo. A couple people had to drop off so that they'd catch the replay later. Everyone's just really impressed. This was a fantastic demo of what is a relatively complicated product. Complicated just because it's so feature rich, but you've done an excellent job of showing people the power and functionality of it. I'm impressed.
Thank you.
Yeah, so Santa Kumar, the repo that Gaurav posted is currently private, but just check back in a few days and he'll clean it up and make it public. So he just posted the link there so that you have it, but check back on it.
Yeah, in a few hours it should be fine.
Oh, come on, I gave you days. Look at you, putting yourself on the spot. Okay, so we got some simple questions rolling in here that are directly related. Turn my camera back on. Hey, there I am. Look, it's getting dark outside. Mosen, unrelated question, not related to the thing, but he asked, what's the local cluster? Whenever you install Rancher into a Kubernetes cluster, the cluster where Rancher is installed is called the local cluster, and that's what you'll always see. So that just means this is the cluster where Rancher is installed, and then any additional clusters that Rancher manages have their own names. Santa Kumar, the instructions to upgrade from 248 to 252 are in the documentation. You can go to rancher.com/docs, and it's just a regular upgrade. Especially now that 252 is stable, get your upgrade on. Rajesh, I don't understand this question. That was my I don't understand this question face. Can we get some documentation on the Rancher Kubernetes operator? I'm not sure what that. Yeah, so everything that you've seen today, you can get documentation on from rancher.com/docs or docs.rancher.com. It redirects. Fleet itself, you can get more information on that from fleet.rancher.io. If you were looking for docs on something else, let us know. Santa Kumar says demo was fantastic. Thank you so much. And Andrew has a unrelated question. Oh, you've watched my videos. That's great. Thank you. A lot of them are really outdated. It's so difficult to put out content and then keep it updated. I have this like backlog of videos I need to make because I go back and I watch something and I was like, oh my gosh, that doesn't even work anymore. So the place that you can go for more help is the Rancher users Slack. So I will just put that slide back up on the screen here. Oh, I have to make myself the presenter. It's the presenter dance again. Dun, 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 dun. Dun, 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 dun. Okay, there we go. And now, whoops. Hey, there you go. So that's for you, Andrew. You can get an invitation from Slack.Rancher. Well, it's actually for all of you. If any of you haven't joined the Rancher user Slack yet, go to slack.rancher.io, put in your email address, Slack sends you an invitation, and then that's where you go and ask your questions. There's also the forums. Depends on whether you're looking for more real-time stuff or browsing stuff that people have asked before. But the forums are at forums.rancher.com as well. Murali asks, for this demo, was Rancher running on EKS or RKE or K3S?
Well, right now in
Question.
my demo, it was on K3S, but not that it matters. With 2.5, we allow you to run Rancher anywhere. It could be running on RKE, K3S, EKS, AKS cluster because of the backup operator that we showed.
Yep. Okay, and it looks like that's it for the questions. I don't have any outro slides. Whoops, I definitely don't have that slide. I don't have any outro slides. It's been just over 90 minutes. Thank you all for joining us. We hope you learned a lot. We hope to see you in a future webinar. And that's it. The end. Thank you to Gaurav and Bill. And yeah, you guys have any closing thoughts, or we should just wrap up and go home?
No, take 252 for a spin.
Yeah, give 252.
Wait, what did you say?
I just said take 252 for a spin.
Yes, take 252 for a spin. And Bill, what did you say?
I was echoing the same sentiment. Yep.
Okay, that's it. That's our closing thought is go deploy Rancher 252, take it for a spin, and practice some of the stuff that you saw today. Thank you all for joining us. Stay safe. We'll see you soon.
Okay, see you everyone. Bye.